MPLS BGP VPN L3 VPN. All right, and yeah, after that is the cybersecurity part. Cybersecurity part. Okay, so today's course and last day's course is two-part. First, I will introduce you the VPN. It's the addition part, all right? And the second part is the global cybersecurity trend introduction. And this part, actually, if you just view the slide, you will find it is quite boring, quite boring, all about concept, right? And I believe you can view this slide by yourself and totally understand those concepts. But I will also, in order to prevent that you feel boring about this slide, I will introduce you something different, something interesting. All right. Okay. And before we start class, I have to tell you something about the platform. All right. The Huawei e-learning platform. And okay, sorry, I need to transfer to the English. And I still remember when I finished the class of day 3, my first day, I send you a link, right? A website link like this. I'll send you again. And some of you just say that you cannot join the class, but I fixed this problem. Now the limitation is 100 people. I believe that you can join again. And I just sent you the link. Please try again. All right. Because after the class, after this course, you need to review all the parts, right? The AI part, the 5G part, and fixed communication and the cybersecurity, right? And you need to review that. And I remember it should be Tuesday. You will have a final exam. And please remember, you must join this class. I send you the link. You must join this class because the exam is inside of this platform. All right. If you join the class and you will see the page, same as I do. This page, PACD Feature Seeds 2025 training. And after you join this class, and you can click this option, schedule, right? Click the schedule, and you will find there are two options. The first is the training slides, and you can view the training slide whenever you want. All right, and the duration is 1 year. All right, 1 year, and the second is the final exam, and the start time is Tuesday. I find some of you have already joined class, and do remember when you join class, change your nickname as your real name. All right. How to change the name? See, this is you, right? This is you, but I cannot identify you. I don't know the name because I need to record the score of your final exam. So how to change the name? Follow my step. There is a button. There is a button after you log in. After you log in, there's a button. This is my name, account name, and you can see this user center. User center. Okay, click this. And there is a nickname. Name and nickname. Please use your name, just your name, not a nickname, because if by default is maybe some number with some letters, I cannot identify you. Okay, change the name. Please finish that. Very, very important. Okay. All right. And second thing, and any problem about this part, I find that only 50 plus of you join this meeting, and the rest of you, if they don't know that, please mention them. All right. I believe some of those who cannot join us is your friend, and please tell them that. Join to the platform and change the name. Change the name as a real name. Okay. And the second thing is about the extra slide, the addition slide. All right. As you can see, e.huawei.com. I will send you the second link. Okay, this is the second link. And the second link is about Huawei's certification. Huawei certification, but I'm not telling you to finish the certification. I'm telling you how to view the public training slide. Okay, I'll show you step by step. After you open this link, the website, you can see the certification, right? Certification. Use your email account to finish the registration, and you can log in. And there are several options. And the second one is certification. And please choose the carrier certification. All right, carrier certification. Click that. Okay. After that, you can see this is the overview. We have so many kinds of HCIA certification, including the different fields. And the second is the certifications. Okay, our at least my part is belong to Datacom. My part is belong to Datacom. All right, and the today's course I'm going to tell you the VPN stuff, right? And where is the VPN stuff training slide? Here, professional HCIP. See that? Datacom, professional HCIP. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 part. And please choose this one. HCIP Datacom, carrier IP barrier. All right? Click this. Okay. And you will find learning resources, right? Can you see the learning resources? Training material and MOOC exam. Yes. And choose the first one. HCIP Datacom Carrier Core Technology version 1 training material. All right. Click this. And you will find you join to a new page. Carrier Core Technology V1. All right. And because I have already joined this class, and if it is the first time you join this class, you will find this blue button shows enrollment, right? And click that. Click the enrollment, and you will see the same page as I do. Okay. After you click that, there's a keep learning, right? Keep learning. Also, schedule. And if you click in this link, HCIP Datacom Carrier Core Technology V1, okay. Can you repeat this part, please? Okay. I'll repeat the part from when you join the class, you can see this page. Okay, first step is to open the link I send you in the chat box. Can you see that? Okay, I send you again. Yeah. When you click this link, you can see that. You can see this. HCIP Datacom carrier IP barrier. And the second one, learning, right? HCIP Datacom Carrier Core Technology V1.0. Click this, the first one. Okay, the first one. And after you click this one, you can see this page. All right. And there's a button. There's a button. Enrollment. Please click the enrollment. And after you click it, schedule. All right. Schedule. And the training material is inside of it. Okay. Click it. Can you see the course contents? Now we're in a new page. New page. Course contents. Can you see that? Yes. Okay. Course contents. Now you can see all the materials of the barrier network technologies. And today we're going to learn the fourth part. Actually, the title of this part is not correct. It should be IPv4 technology practice. The fourth part, key IPv4 technology practice. All right. Okay, and choose the first one, MPLS basic principles. And you will see the same page as I do. Can you see that? And this training slide, those material is for free. It's for free. Everyone can see that. And you can learn that by yourself. Is that good for you? I hope this can help you. 非常好。Good, good. I believe that you translate this into the Mandarin and send that to me. Okay, thanks. Okay, one more question. Do you still remember my Chinese name? Do you still remember my Chinese name? Oh, good. Someone sent me. Ping Zhengyang. Yes, Gavin. Gavin is my English name. All right. Okay, good. That's my honor. It's my honor. Okay. Then we start this part. All right. The VPN part, because I promise you, is the addition part. MPLS, multi-protocol label switch, and this is the name of MPLS, and it is also one of the key technology in the carrier network. Very, very important. If you want to learn the VPN, you have to know what MPLS is. And one thing I need to tell you is one sentence, all right? One sentence is all kinds of VPN technology. It's just one word. And that word is encapsulation. Encapsulation. I hope my pronunciation is good. Every VPN technology, if I make a conclusion, it's just one word, is encapsulation. Because if for the origin packet, we just use the private IP address, right? The private IP address. For example, 10.1.1.1. It cannot be routed in the public network, right? We cannot route that. If everyone uses the 10.1.1.1, there are so many 10.1.1.1. How do we distinguish, right? How do we distinguish? So we need to put some header above that origin packet to change that. And that is encapsulation. All right, that is encapsulation. And of course, MPLS is also one of the encapsulation technology. Very important. Okay. And let's see the training slide. Okay. And this is the very classic topology. There are four routers, router A and B and C and D. And they are already deployed in our carrier network. And they need to transfer, they need to transmit several packets between two sites. And the site's IP address is 10.1.0.0/24. And destination network is 10.2.0.0/24. All right. Obviously, these two network segments is the private one. In order to transmit those private IP address packets through the public network, we have to use the MPLS. Okay, let's see. Network 10.2.0.0/24, and this is the routing table of router A, right? Routing table of router A. And this is the traditional IP forwarding. Check the routing table. Do you still remember what routing table is? I remember the first day, I draw you a picture. I draw you a picture to show the logic between the BGP, ISIS, OSPF, and the routing table. I show you several boxes, right? The boxes. The biggest one is the routing table, and a smaller one. I also draw you several smaller boxes. OSPF, static, direct, BGP, right? And they are different routing protocols and independent for each other. And the routing table, choose the best one, the optimal one from each box. And this is the result. And for the traditional IP forwarding, if a router received a packet, the first action is to check the destination IP address to find out where to go. For this packet, where to go, right? Destination. And the destination of this packet, in this scenario, the destination is 10.2.0.0. And check the routing table. Okay, the last entry. See that? The last entry. Next hop is 10.1.1.2, which means the router B. The router B, right? Okay. And router A send the message to router B, and router B do the same thing, same procedure. Again, check the destination IP address and check the routing table. Find the matched entry, the last one. Okay, send to the router C, send to the router D, and finally attach to the final destination, right? Okay, this is the traditional IP forwarding. Okay, just ignore the ATM. Ignore the ATM. It's a very old technology. We don't use that anymore. And MPLS label forwarding is different. And that this page, traditional IP forwarding, is using the IP routing table, right? Routing table. But MPLS, we will establish a new table. And it is called label forwarding table. Different. But the label forwarding table is based on the routing table, which means we need to have the routing table first. Then we can enable the function of MPLS. And then we can have the label forwarding table. And then we can use the MPLS to forward the traffic to finish the encapsulation, right? See that? The packet, IP header, and the data. And this is the origin part. And we put something to the origin packet Can you see this green part? And this is MPLS header. And you may ask one question. Where does this MPLS header coming from? Where? Okay. Once the router ABCD, they enable the function of MPLS and LDP, they will assign the MPLS for each link. For example, router B will assign a label, MPLS label, to this link between the router A and B. And the router BC will also assign a label for this link, S3 to S2, right? And C and D, same. And this is the label. Where does this label coming from? From the devices, from the routers, all right? Okay, since we know MPLS, then we can move to the MPLS VPN application. And this is a very classic, very classic scenario. And you can see there is a frame. There's a frame in the color of gray. And it is called MPLS domain, which means those routers is the carrier network routers. And they all enable MPLS. They all have the function of MPLS. And the CE is the router which belongs to the customer. For example, VPN-A, this router, the first router is belong to Huawei company. And the second one may be Cisco, Nokia, or someone else, or Google, or Apple, right? Different company. And in order to forwarding the traffic from the VPN-A to the right side VPN-A, for example, the VPN-A in the left side is in Beijing, for example, and the right side VPN-A is in California, USA, and they need to transfer the traffic. They need to transfer the traffic through the public network, which means the MPLS domain. And the Cisco company, same. They have the same requirements, but the private IP address, they use the same. 10.1.1.0. How to distinguish, right? The answer is MPLS VPN. Okay, let's see how to distinguish. And this is a T. We can sorry. I forgot to explain what does this mean. What is the meaning of CE? What is the meaning of PE? P. Does anybody know that? Anybody know this? The meaning of the CE, PE, and P. Yes, good. PE, provider edge. Yes. What about P? A provider, yes. And what about CE? A customer edge. Good. Yes, exactly. Okay, and these are the T part. And this is how MPLS network work. Several concepts. LER, label edge router, and LSP, label switch router, and LER also label edge router. LSR switch, LSP, label switch path, and just like a tunnel, just like a tube, a pipe. Okay. Why the shape is like a pipe, a tube? Because the origin packet after encapsulation, it's just like we put something into a tube, and that tube is the tunnel, and the tunnel is the encapsulation, is the MPLS header. All right. And this is the location. And this is the location of MPLS header between the layer 2 and layer 3. Between the layer 2 and layer 3. And the layer 2 is about the MAC address and the VLAN information, right? And the L3, layer 3 is the IP layer, IP address, source IP address, destination IP address. And MPLS header is between them. So we call MPLS is a 2.5 layer technology. Layer 2, layer 3. So MPLS is 2.5 layer. All right. And I also told you, I remember the first day I tell you, the header length of the MPLS is fixed 32 bits, right? It's not flexible, is fixed, is fixed. That's why we need MPLS. Because for the very, very old devices, if they try to forward the traffic, the header length is flexible. It will reduce the efficient. Maybe for the forwarding procedure, it will slow down the speed. Very, very slow. But if every packet's header is the same length, okay, faster. So that's why we need MPLS at the beginning time. But nowadays we use MPLS as the VPN encapsulation. Okay. Okay. And I also tell you that one thing, the label forwarding table is based on IP routing table. We need to have the IP routing table first. Then we can have the MPLS label switching table, right? And there's one more thing, FEC, forwarding equivalence classes, which means one entry in the routing table, which means the destination. For example, I am the router A. I have several entries in my routing table, and one of the entry is 10.2.0.0. I can check the next hop, right? And this is a FEC. And if the router, now I'm a router, I just enable the function of MPLS, I'll check each destination. I will check each destination on my routing table, and each one is a FEC, and I will create a label number for this FEC. All right, and that is why we can see the green part is a label. There's a number. Actually, I allocate the number for this label and tell the router B, if you want to send me the message to 10.2.0.0, okay, put a tag, put a MPLS tag, push a tag into the origin packet, and this label number should be 1024. All right, is that clear? Is that clear? Okay, yes, good, very good. And now we can back to this page. We can move to this page. See that? This is the relationship relationship between the MPLS and the routing protocol and the routing table. See that? Two plan, control plan and data plan. Control plan and data plan. Control plan is just like the SIP, the signaling. It is a signaling protocol. And for the MPLS, same. Same for router, same. We have a control plan. It's just like the brain, our brain. Think where to go, how to go. And the data plan is how to just execution, right? To plan. And a control plan including the routing protocol. Routing protocol. For example, static route, direct route, OSPF route, ISIS route, and of course BGP route. And these are the routing protocol. And because we have the routing protocol, then we have IP routing table. It's step by step, right? One step by one step. And now we have, since we have the IP routing table, then we can allocate the FEC, right? Because IP routing table have so many destinations, and each destination is one FEC. Okay, then we can create based on the label distribution protocol. And what is label distribution protocol? And it is called LDP. Because the router A need to tell the router B, if you want to go 10.2.0.0, please put on a tag. And the tag number is 1024. And how does router A tell the router B? They need a language, right? They need a language, and that language is LDP. It's distinguished from the routing protocol. It is different from ISIS, OSPF, direct, static, and BGP, all right? It's an independent protocol. It's called LDP. Okay, since we have these three elements, then we established data plan, IP forwarding table, label forwarding table, right? Label forwarding table. Okay, this is the relationship between these elements, all right? I think this page is very important. It can help you to understand. And see, incoming IP packets. First, check the IP forwarding table. And if the packet without a MPLS label, then check the IP forwarding table, traditional IP forwarding. And if the packet do have a label, then check the label forwarding table. And this procedure, see that the green arrow, faster, okay? Okay, see this scenario. This is the output from a real router. The FEC is 10.2.0.0 and the out label is 1030. 1030. And actually this label is coming from the remote side. It's coming from the remote side. If the router A need to send the packet to the router B, which means this 1030, this one, the router B tell the router A, all right, through one protocol, LDP. Okay, and several, this is the label forwarding table. FEC, next hop, out interface, label operation, and others. Easy to understand, right? It is different from the IP routing table. FEC corresponding to the IP routing table destination, right? And next hop, same, just next hop. And out interface, same interface with same with the IP routing table. But the different thing is the label operation. The label operation have three three types. First, push. Second, swap. And third one, pop. Push means if it is the first hop, which means the router A is the first hop, first router in the MPLS domain. The router A will receive a packet from the customer, and the customer's router do not enable the MPLS. So the customer's router just send a origin packet. See that without a MPLS label, which means the router A need to push one tag, push one MPLS header. So the behavior of router A is push, add a new one, right? Okay, and what about the router B? Let's see. Router B. Now the label operation is swap, which means shift, change a new one. Change a new one. Why they need to change? Why? Because the router A 1030, this label is router B tell the router A, right? And for the router B, this label should be the router C tell the router B. Oh, I think this page is not so good because the router A's label and router B's label, the number is the same. But actually in the real network, maybe different. Maybe different. Or maybe router C tell the router B. If you want to forward the traffic to the 10.2.0.0, please put on the tag and the number is 2030, maybe. All right. So for the router B, when the router B receive the MPLS packet from router A, okay, change the MPLS header to the new one, and the new one should router C tell the router B, right? Okay, according to my description, you will find one thing. According to my description, you will find one thing, which means the forwarding path, LSP, label switching path, before the traffic come, already established, right? The forwarding path already established before the real traffic come, right? And that's why the router A and B and C and D know how to put a new tag, how to change, how to swap the tag, right? Is that clear? This is very important. Yes? Okay, good. Clear, good. Okay, then router C. Okay, let's see what will the router C do? Swap, because it is not the last one. It is not the last one hop. Okay, see that? This time different. This time is 1032 because this 1032 is the router D sent to the router C. All right. So we can say one sentence, make a conclusion. Make a conclusion. The direction of LSP establishment, how to say, the LSP establishment direction is the opposite way from the traffic. So the router exchange information twice. First to get the, let me check the information. First to get the pass straight, and the second to actually pass the information. Right? Yes. First to establish. First, they need to establish the LSP, label switching path. Then they can transfer the real traffic. And the traffic direction is the opposite way from the LSP establishment direction. right? Because you can see the traffic is from left to right, and LSP establishment is from right to left, right? Okay. And maybe some of you will ask me one question. The traffic from the left to left to the from left to right is just a come. And what about go? After the 10.2.0.0 receive the traffic, it will reply and send back to the 10.1.0.0, right? And this is another direction of traffic, and which means the traffic from 10.2.0.0 to 10.1.0.0 also need to establish an LSP. Okay, we assume that this 10.1.0.0 is Alice, and 10.2.0.0 is Bob. Alice and Bob communicate with each other. How many LSP will those router create? How many? 2. Good. Yes, exactly. Come and go. Okay. Okay, I think you got it, right? And let's see, what will the router D do? What will the router D do? Because the router D is the last hop. The router D need to send the packet without a MPLS header to its real destination, which means the router D need to remove the MPLS header. So label operation is pop, P-O-P, which means remove. All right. Okay, I think it is clear. I think it is clear. Okay, now you have the basic knowledge of MPLS. And and this is the way to do the configuration on Huawei router. We need to take some command to tell the router how to do. Let's see the command. The training slide don't have the command. It's okay. It's okay. It's okay. The command is very, very, very easy. Just MPLS, enter. LDP, enter. Okay, finish. And this is the establishment. These pages shows us the establishment of the LSP. You can see display MPLS LSP include 10.1.0.0. This is the FEC, right? This is the FEC. And the router B, check this. And output, see that FEC, this one. This is in label, 1029. 1029 is coming from router A, and the router B tells that, right? Okay. And this is the LDP. LDP, I told you what is LDP. Because in order to exchange the label information between routers, they need a language. And that language is LDP. And this is the way how the routers establish a LDP session. They need to send several packets. Hello, SYN, ACK, and SYN. It's just like a TCP three-way handshake, right? Okay, and keep live address label mapping. Easy to understand. Okay, since we have the basic knowledge of the MPLS basic, then we can move to the BGP, MPLS VPN. We need to move to the, I think is page. Okay, chapter 11, chapter 4.11, BGP MPLS VPN, page 6. Page 6, because this is online material, so everyone's page number is the same. And you can see the VPN classification, which means the types of VPN. Overlay VPN, peer-to-peer VPN, MPLS BGP VPN, and L2 VPN, L3 VPN. We just need to know the mainstream, the VPN type, IPsec, GRE, MPLS VPN. And MPLS BGP VPN is widely used in the carrier network. And IPsec also, but IPsec also used inside of one enterprise headquarter connect to its branches. They need to use the IPsec. Very, very useful technology. And GRE, same. But the GRE do not have the function of the encryption and decryption. It's not safe, not safe. But IPsec have the security function. Actually, it's the cybersecurity part. As you can see, very classic topology. Huawei send the traffic to its branch, and Cisco send the traffic to its branch, but through the public network. Okay, this is the traffic forwarding path, traffic forwarding direction. Route transmission from the CEA to the CEB. Now, I'm going to introduce you is the L3 VPN. Do you still remember the differences between the L3 VPN and L2 VPN? I mentioned before in the first day. What is the difference between L2 and L3 VPN? The layer. Yes, the keyword is the layer. Yes. Okay. For the L2 VPN, after the origin packet go to finish the encapsulation, the origin packets L2 to L5 information still remain. All right, still remain. And that's L2 VPN. But L3 VPN is after encapsulation. The L3 to L5 information still remain, still reserve. But the origin packets L2 information, gone. That is the difference between L2 and L3 VPN. And of course, now we're talking about the BGP MPLS VPN. It is the L3 VPN. Okay, let's see how does the L3 VPN work one by one, step by step. First is exchange of route information from the local CE to the ingress PE. See that HQ of company A, site A, they need to send the route information to the PEA. Because why the CEA need to send the route information to the PEA? Because the other side need to receive this message. Otherwise, the branch router, the branch devices don't know where is headquarters, right? So the CEA need to send those root information message to the PE, ingress PE. And of course, the PE is the provider's edge, which means this router is belongs to the carrier network. And it needs to send to another PE, maybe PEB. And the PEB send those root information to another C of company A. Maybe company A, site B, right? And so the first step should be CA send the root information to PA. What kind of routing protocol they use? So several, right? BGP, OSPF, ISS, RIP, and static. They can all use that. It's okay. But I recommended you to use the BGP. See that? BGP. Because the BGP is used to control the root information itself, right? BGP is made for root control and sending. So I recommended you to use the BGP. Very, very useful and flexible. Okay, and then change of root information from local C to the ingress PR. Second, distinguish the different private network routes by the PE VPN, routing and forwarding. Okay, it seems like a little bit complicated. You can see a keyword in this page is VRF for site A and VRF for site C. Site A is belong to the company A, and site C is belongs to company B. And what is VRF for these two sites? What is VRF? Do you have any idea of this one? It's crucial. Virtual routing and forwarding. Yes. I maybe the rest of you don't know that. Okay. I think it is necessary for me to root in the slide. Yes. Good. I'm gonna explain you the why we need this thing. I need to share my pad. Okay, wait a minute. Wait a minute. Okay, now you all of you can see my pad, right? Can see my pad. Okay, this is a router, right? And PE. And by default, virtual routing and forwarding represent isolated and independent routing table about the traffic. Yes, exactly. Your answer is correct. Absolutely correct. But I need to tell you the logic. The VRF is just like a virtual router. You can think the VRF as a virtual router inside of a physical router. And this router P is a physical one, right? Is a physical one. But once we create a VRF, okay, but before that, by default, there's a default routing table, IP routing table. This is a default one, also called the public one. The public routing table, by default, every router have one. But sometimes we need to create a VRF. Oh, sorry. VRF. Company A. and company B. Because they have the same, they use the same network segment, 10.1.1.0. Okay, and company A, 10.1.1.0/24. Same. So when the root information sent to this router, okay, sent to this router P, the P cannot distinguish which 10.1.1.0 is from which company. They don't know that. The router don't know. You have no idea. So we need to put the corresponding root information into a specific box, and that box is the VRF. And this VRF is belongs to, bind to, match to the company A. For example, VRF A. And this is VRF B. VRF B in color of blue. Bind to the company B's device. And the 10.1.1.0 root information go into the box of VRF A. And the 10.1.1.0 root information go to the VRFB box. They are isolated and independent. All right. Okay. So the VRF, actually, the essence of VRF is a virtual router. Because by default, one router only have one routing table. It's the public one, right? But this is not enough. This is not enough. In order to distinguish the same root information from different company, we need to create two more the new routing table, which is the VRF. Every VRF have its own IP. Every VRF is a virtual router, all right? Equals to virtual router. A logic router, not the physical one, inside of the physical router. And this interface, there's one interface bind to this VRF, and the router, this P, another interface bind to the VRF, connect to the company B. Okay, and okay, the 10.1.1.0/24. This entry now, how many VRF can be created in a single router? Okay, there's so many. I remember so many students ask me this question. Actually, no limited. As long as the router have enough performance, enough resource, it can create unlimited VRF. All right. Depending on the, how to say, hardware performance resource, how the companies know to send the information to their corresponding VRF? Good question. Good question. Actually, the company don't know. The company don't know. They just need to know. I sent a message. I sent a message to the PE. I don't know what happened on PE. I don't know how many VRF does this PE have. They don't know. The PE will help the company to distinguish. The customer no need to know. The customer no need to know. All right. Because every company have a corresponding interface on the router, the physical router. All right. For example, this black interface number is 001, and this blue interface number is, for example, 002. And the 001 is connect to company A, and the 002 is connect to company B. And these two interfaces also bind to the corresponding VRF. So VRF is like a disk partition when we talk about the resources, right? It's not a disk partition because the disk partition need to allocate the storage space to the different virtual machine. But router, the VRF is not a virtual machine. You just understand, you just think the VRF is to create a new sub IP routing table in one router, in one physical router. All right. And after we create a VRF A and B, how many routing table inside of this router PE? How many? Uh, Someone tell me two, and someone tell me three. Of course, it should be three. It should be three. Public one, two, and three, right? One should be three, not four, not two. And each routing table, 1, 2, 3, is isolated from each other. Is isolated by default. Okay? That's why the router can distinguish the root information which is coming from the different companies. All right? Okay. And that's VRF. Is that clear? What happens if too many VRF are configured on the PE? Does it affect the efficiency of the communication? Yes, of course. Because if you configure too many VRF, it consume the hardware resources, of course. And for the configure, for our engineer, we manage the router, right? And we need to remember how many VRF we create. And we need to do the configuration. And of course, the more the VRF we have, the more resource it takes, of course. It's like a defined IP table, something like that. Okay, got it. Yes, good. Okay, since we already know the step, already know what is VRF, okay, I draw another router. We assume that this router P is router A, RTA. All right, now we have router B, RTB. And between the router A and the router B is the carrier network. Maybe 100 routers. Maybe 100 routers. So many. But we don't need, there's no need for us to know each router in the carrier network. In this scenario, we just cares about these two router A and router B, two PE. This is another PE. Okay. Company C, company A. And this is company B. All right. Sorry, I need to take a screenshot. 1 minute. Okay, I'm back. Let's continue. Since the router B connect the same two company A and company B, but it is branch, right? It is branch. This is branch. The purpose is company A headquarter try to send something to the branch company A, and company B headquarter HQ send a message to company B branch, right? Okay, so of course the router B need to create the same VPN instance. The same VRF. VRF. VRFA. Okay, this is VRFB, right? And the root information exchange between the corresponding VRF. The router A VRFA send the root to router B VRFA, right? Okay, and router A VRFB send the root information to the router B VRFB. Isolate, right? VRF is like a VLAN that operate as layer 2. Oh, sorry. VRF is a layer 3 concept. It's layer 3, not layer 2. Not layer 2. All right, it's about IP. The VRF is all about IP, not layer 2. Okay? Okay, for now on, can you understand? Am I clear? The logic, the relationship between the VRF and the VRF. Yes, good. And that's how VPN work. This is the basic. Okay. And now maybe you have one question. How to transfer those root information, right? You said the router A send the root information to router B, VRFA to VRFA, VRFB to VRFB, right? But between the router A and B, we still have 100 routers. Which means, does that mean in those 100 routers, each of them need to create the VPN instance VRF A and B? Yes or no? Question. Yes or no? No, the answer is no. All right, because this 100 router is just a P router. They are all P router, not PE. Only PE router need to create the VRF. For the P router, no, not necessary. Not necessary. Okay, now you know the result. You know the answer. Okay, since I told you the P router no need to create VRF, then some of you may ask me one question. You said the root information need to send across the P routers, right? But how does the P router distinguish the root information from the VRF A and B? That is the question, right? Yes. Yes. Okay. Now we need MPLS. Okay. Actually, the answer is BGP. Is just the BGP. In order to switch to exchange the root information between PEA and the router A and router B, they need to establish a BGP relationship, the BGP neighbor relationship with each other. All right. I use the green. Okay, green color. BGP. And I told you, what is the function of BGP? It is used to send the root information. right? Okay, then let me use this IP forwarding and MPLS label. Yes, I'm not finished. Okay, let me explain. The BGP for those P router, there is no need for them to read the information. There's no need for the P router to read one is belong to company B. But when these traffic sent to the router B, how to distinguish? The router B receive the route information, the data part, and including two route information, how to distinguish? They need the router B needs something to identify. The first entry need to go to the VRFA, and the second entry need to go to the VRFB, right? The router B need that. Okay, so that thing is called RT and RD, route distinguisher and route target. Do you need a break? Do you need to take a rest? It's already 1.5 hours. Okay. Take a break for 10 to 15 minutes. All right? 10 to 15 minutes. Then we go back and continue.